So in today's class, we'll be discussing about the application of SR Latch. So this is in continuation with your previous class where we discussed about the working of SR Latch, and we discussed about what is latch and how we use it using a SR Latch. Now the first application that we are going to discuss in today's class is your switch debounce circuit. So basically, what is switch debounce circuit and how we can avoid this debouncing of a circuit or a switch using a SR latch. That is what we are going to discuss in today's class. Fine. So students, you can see here there is a switch that I have designed. Okay, so it has 2 points, A and B. So normally you have a switch, okay, where it is an on state or in an off state. This is a power supply that I am supplying to the switch, and the power supply that I am supplying is of 5 volts. Okay, and this is the center contact. This is a center contact. What do you have? So what you are going to do? So as and when now here this is getting connected, this is moving. So like this will be moving here. Okay, this will be moving and it will be connecting here like this. So I can move this center of contact from one point to another point. So we have 2 points, point A and point B. Now what happens when I supply a 5 volt power supply to this center of contact, and if the center of contact is currently pointing towards the bottom part of my switch, then what will happen? A 5 volt power supply will start flowing to this point B. A 5 volt power supply will start flowing from this point B. And when I move this center of contact from the lower point to the upper point in this manner, when I move this center of contact, this arrow which is currently pointing towards the lower end of the switch, that is towards B, I move this center of contact to the upper portion of this switch, that is to A. Now if I make it connected to this, now what will happen? The voltage that will be there at B will be 0, and the voltage now at point A of this switch will be equal to 5 volts. Okay, the supply stops to point B, and now the supply will be supply starts flowing to point A. So this is normally how the switch works. This was just a general explanation what I'm giving. This is a switch where we have 2 points, point A and point B. Point A is at the upper portion of the switch and point B is at the lower portion of the switch. This arrow pointing towards the lower portion of the switch is nothing but a center of contact which we can move from one point to another point, that is from point A to point B. And to this center of contact I have connected a power supply which is a 5 volt, where this power supply, when I put it in a on state, okay, the power supply will start flowing to that particular point wherever this point of contact is connecting. Now currently you can see this point of contact is connecting to the lower portion of the switch, that is towards B, and now initially what will happen? At point B you will have 5 volts coming, 5 volts coming, and at point A you will have 0 volts, you will have 0 volts initially. But when I move this point of contact from the lower portion of the switch, that is from point B to point A, from point B to point A, at that moment what will happen? The voltage currently that was there with B will now reduce to 0 volt, and the voltage at point A which was earlier with 0 volt, now it will have 5 volt. So this is how the switch works. Now, what is basically switch debounce? Okay, so the common problem when we use such kind of a switch is that the contact bounce. So what is that contact bounce, and how we can avoid this contact bounce problem using SR latch? That is what we are going to see. Now basically students, when I move this contact point, the arrow, from the lower portion of the switch, that is from point B to point A. Now what happens is that whenever I am moving this arrow from the lower portion to the upper portion, as I have shown it in a dotted arrow, what will happen? Once it gets connected, okay, it will touch this particular point A, and it will bounce back. It will bounce back for one or two times. It will bounce back for one or two times, and then finally it will get connected to point A. So before the final connection happens of this particular contact head with the point A, it will bounce back twice or thrice before it has a perfect or final connection happening with point A. So it will just keep on moving from up and down before it has a final connection. And this is what the problem, we call it as a switch debounce. The switch or the arrowhead which is connecting from point B to point A will bounce two or three times. Okay, it will bounce before it gets connected two or three times, and then in the final point it will get connected. This you can understand with an example, with a graph that I have shown. So initially you can see here that in the start initial stage of this particular circuit, what you can see here is that, okay, we have the 5 volt supply going through this point of contact, and this 5 volt supply is moving to point B, as this arrowhead or connector, center of contact connector, is connected to point B. Now here you can see voltage at B. What will be the voltage at B? Voltage at B will be 5 volts. Voltage at B will be 5 volts. What will be the voltage at A? Voltage at A will be 0. Why it will be 0? Because there is no connection happening. So this arrowhead is connecting to the lower portion of this particular circuit, that is a switch, that is point B. So the current which is coming out from the voltage source is flowing directly through point B, whereas point A will have 0 volt supply. So this is shown in the graph what we have. Okay, now what happens when I move this arrowhead? When I move this arrowhead or a point of contact, what I am telling, this one, the point of contact, from the lower portion of the circuit or the switch to the upper portion of the switch, that is from point B to point A, as I have shown it in a dotted arrow. Okay, what happens is that when I move this arrow from point B to point A, at that time there will be a sudden fall in the current that is flowing towards point B. There is a sudden fall in the flow of current at point B, and point B will be having no voltage, that is we represent it as a 0 volt. That you can see that suddenly when I move this arrowhead from point B to point A, the current has fallen down and we move on to 0 volts. But you can see when I'm representing the voltage at point A, what is happening? There are some pillars coming out. What are those pillars? These pillars are nothing but the, whenever this arrowhead is trying to connect to point A, once it gets connected, it will bounce back. It will bounce back. It will bounce back and it will again go back to point A. So this may happen 2 to 3 times. So it will connect, it will come back, it will connect, and it will come back till it settles for the final value. So whenever it connects, you can see there is a high voltage, that is 5 voltage, that is being flown at point A for a given time period. Okay, because it has got connected, suddenly there is a 5 volt flow happened in point A. It connected and it bounced back from that particular connection. So when it bounced back, what happened is that the flow went, and suddenly there was a fall inside the voltage that was flowing at point A, and suddenly the value of A was 0 volt. So again it went back to point A, it got connected, and there was a 5 volt connection happening. 5 volt connection happening, and then finally it got connected to this point, and then you can see there is a 5 volt constant supply happening. There is a 5 volt constant supply happening at point number A. After bouncing back 2 or 3 times, what has happened? The switch has finally able to settle down with point A, and then there is a power supply happening from the voltage source to the point A of this particular switch. This is how we have shown in this particular graph. So at the x-axis we have the time, and y-axis we have the voltage source we are showing in this particular graph. Once we move back, once after certain time, once we move back from the point of contact that we had earlier, that is from point A to B. Now I am moving back from A to B and switching back from A to B. At that time, what will happen when I switch back from A to B? Suddenly there will be a fall in the current. There will be fall in the current at point A. It will fall in the current at point A. So point A will be having 0 volts. You can see in this graph there is a sudden fall in the current that was flowing at point A, and what happened? This arrow head got connected with point B. This arrowhead got connected with point B, and once it got connected, initially it bounced back. Initially it bounced back. Again it came back. Again it came back. Okay, again it bounced back. Okay, before it settles down to the final value, it bounced twice. So this you can see here. It got connected. So there was a 5 volt supply happening at point B. Then it got disconnected, so there is a time delay here, there is no flow current, and then after that once again it got connected and there is a 5 volt connection happening. Okay, and after certain time it finally settled down to point B. It finally settled down to point B, and you can see at point B we have the 5 volt supply happening. Okay, so this is what the problem, students, you can see with a switch debounce. This is what the problem that you can find with the switch debounce. That is, the switch will never settle down to a one value at a given point of time. It will make certain variations before it settles down to a final value. So here you can see the two pillars here and the two pillars here show that the contact switch, when it is moving from one point to another point, okay, is not settling to a certain value at a given point of time. So it is moving, connecting and losing its connection, connecting and losing its connection before it settles down to a final value. So this problem is overcome using a SR latch. So this problem of switch debounce we are trying to overcome using a SR latch. So SR latch, we have seen in the previous class what exactly is SR latch. S stands for set and R stands for reset. We call it as a set reset latch. Okay, and how it is going to latch the output value to a single point of time. So that is what we have seen. Now this is how the SR latch is going to be used in making the circuit switch stable to achieve the value at a given point of time. That is what we are going to see here. Now this is what the SR latch is. So this is an SR latch what we have. Okay, SR latch, S stands for set, R stands for reset. The input of the switch is connected to S, and another input of B, switch B, is connected to R. So A we call it as S and B we call it as R. So this again, the switch is going to have a 5-volt power supply, and initially it is connected to point B, that is to the R input of the SR latch, and then we have the two outputs Q and Q bar. So Q bar is a complement of Q. So this is how the student we use a SR latch to avoid the switch debounce circuit. Now let us understand how this SR latch is going to avoid the debouncing of the switch before it settles down to a final value. So we can understand this with a graph that we have taken here. So before that, you should understand the truth table of a SR latch. So the truth table of SR latch is, the truth table of your SR latch is, okay. So we have the input S and we have the input R, then we have the output Q, and okay, we have the output Q, and then we have the next state. We represent it as Q plus, and then we mention the state. Okay, in which state that particular condition is. So initially it will be 0 0, then we have 0 1, 1 0, and we have 1 1. So you can have this truth table given. Then if you look into this, what is the state? This will be Q, and this will be in Q bar state. What is the first state, students? This is a previous state. What you have? We have this previous state. This is your previous. Yeah, the first state is your previous state when it is 0 0. When it is 0 1, okay, when it is 0 1, what is that? We are going to tell it as a reset state. The Q value is 0, Q bar is going to be 1, that is the next state is going to be, we call it as a reset. We call it as reset. We call it as reset state. Fine. And then when we have S is equal to 1 and R equal to 0, we have Q 0, the next state will be Q as 1, next state will be 0, and we call it as a set state. S-E-T. That is your set state. Yeah, we have the set state. And then when both the input S and R are 1 1, so we don't know what exactly the state the flip-flop is going to be. So the state what we are going to define is your undefined state. We have the undefined state. So here you can see I was talking about the SR latch flip-flop where we have S and R as the two inputs. Qt plus 1 is the next state. Okay, so at time next state of that particular flip-flop. So when S and R are 0 0, Qt is the previous state what we are going to have. When S is 0 and R is 1, so we have the reset state. We have this reset state. When S is 1 and R is 0, we have the set state, and when S and R are both 1 1, we have this undefined state. So remember these states. This state will be discussing just with respect to the switch debounce circuit. Now see here, we have seen how the switch debounce circuit is working. So it is not settling down at a given point of time for a change from one point to another point. So here you can see initially we take S and R. So here you can see S is 0. When S is 0, what is the value of R? Now here R, there is a 5 volt supply happening, so there is a current flow and we term it as 1. So when S is 0, when S is 0 and R is 1. When S is 0, R is 1. What is that? What is the output Q? What is the output Q? So output Q is 0. So output Q is 0. So here you can see there is no supply of current happening. There is no supply of current happening at voltage A. As Q bar, there is 1. So at Q bar, this is 1. So I take it as Q and this I take it as Q bar. Okay. So Q bar, there is 1. Okay. So there is a supply happening. Now here when there is a fall on current, so here you can see S is now 1, there is a current flowing, and R is 0. R is 0 at this particular point of time. You can see it. S is equal to 1 and R is equal to 0. R is equal to 0. Now here what happens when S is equal to 1 and R is equal to 0? What is Q? Q is going to be 1. So here we have a 1 coming out. So here you have a 1 coming out till here. Just till here you have a 1 coming out. Okay. Now there is a fall in the current in S. So we have a 0 here. So we have a 0 here. So R is also 0. So R is also 0. So there is no current flowing in S also at a given point of time. There is no current flowing in R also. At that time when S and R are 0, 0. When S and R are 0, 0. So what is that? Q. What was the previous state of Q? 1. So it will remain. So that we call it as a previous state. What was the previous state? Initially Q was here. So we have to continue with the same state. So I will extend here till here. I will extend it till here. Now till here you can see, till here you can see what is that? The output of VA is going to be high only. Now what is happening? Now S value is 1, S value is 1 and R value is 0. R value is 0. I am talking about this. I am talking about this. Okay. So till here the value of Q is going to be the same. So when S is 1, R is 0. When S is 1, here R is 0. What is that? Q should be 1 only. Q should be 1 only. So I am extending this till here. So I am extending this till here. Okay. Now what happens? See here, after the current has fallen down at S, we have 0 coming and for S and 0 coming for R also. When it is 0, 0, again I have to take the value of Q only. What is the value of Q? It is the previous state. What is the previous state? Previous state of Q was 1. The previous state of Q was 1. So I extend here. So I extend here. So I extend here. Okay. So I extend here. Now at this particular point of time, you can see here at this particular point of time. So here in VB you can see that till QA is 1, okay, Q is 1, Q bar is going to be 0 only. Q bar is going to remain in 0 state because Q bar is a complement of Q. If Q is 1, Q bar will be always 0. Now at this particular point of time, what is that? S is 0. S is at this particular point of time, S is 1, S is 1 and R is 0. S is 1, R is 0. So when S is 1, R is 0, what is the value of Q? The value of Q is 1. You can see here. So still it goes on continuing to remain in the high state and Q bar keeps on continuing in remaining in the low state. Okay. Now here you can see when the R value changes to 1, when the R value changes to 1, the q value, s value changes to 0. So s value changes to 0. So when s is 0, and r is 1. So when s is 0, r is 1, what is the value of q? The value of q is 0. The value of q is 0. So here you can see, when the value of r changes from 0 to 1 and the value of s changes from 1 to 0, there is a fall in the value of q. Suddenly it becomes 0. So it becomes 0 because q value is 0, and now q bar will be 1. So it will change. So here you can see why, because q bar is the complement of q. So q value will rise, q bar value will rise and q value will go down. Okay, now after that you can see the s value is 0 as well as r value is also 0. So when s value is 0 and r value is 0, what we say? 0 0 q, that is the previous state. What is the previous state? My previous state that you have to be in the low state only, so the q value remains 0 only. Now when s is 0, r is 1. When s is 0, r is 1. When s is 0, r is 1, what is the value of q? The value of q is again 0. So still it continues to remain in the same state, that is 0, and q bar continues to remain in the high state. Okay, now when s is 0, and r is 0, so here we are here currently. Okay, we are currently here. Okay, when s is 0, r is 0. When s is 0, r is 0, q, that is previous state, so still remain in the previous state. Q bar also remains in the same state, that is the complemented state. Now here s is 0 and r is 1. When s is 0, r is 1, I am talking about this state. When s is 0, r is 1, q is going to be 0 and it continues to be in the same state. It continues to be in the same state. So here you can see that even though there is a change in the switch, that is the switch is changing from a to b or from b to a. So here it is going from b to a, or it is coming from a to b. Whenever there is a change in particular point, when it is changing from b to a, or it is from a to b, you can see we have achieved a stable state. Q is 1 and q bar is 0. Here q is 0 and q bar is 1. Okay, so there is no change or value changing at this particular point. So using SR latch, students, you can see that we are able to achieve the stable state using this, or we are able to give a stable state to this switch that we have designed using a SR latch flip-flop. Okay, so the using a SR latch, so we are able to achieve a stable state which was not possible earlier with this particular switch that we had, where we could not get the exact value of a and b at a given point of time, where we could not have a stable value at point a and point b, and this we could achieve using this SR latch, using your SR latch. So the switch debounce can be avoided using your SR latch. So this is what is the explanation for your today's class. Hope you have understood it. Thank you.